Hi everyone, in this lesson we're going to be combining calculus and trigonometry. So we're going to be differentiating trigonometric functions. So let's have a look at some basic derivatives. Let's say we have y equals sine of some linear function ax plus b, and it can extend beyond linear functions, but this is primarily the focus of this course, linear functions in trigonometry. And if we differentiated this, we would end up with y dash equal to sine will turn into cos. You'll get a cos ax plus b. So I'll take you through all that, what happened. The number out the front here, a, is the derivative of this, is the derivative of that linear function in there, and this does extend beyond linear functions. So the derivative of that is out the front. The next thing to remember is that sine will turn into cos. That is the change of the trigonometric function. So it used to be sine, now it is a cos. So sine will change into cos if we differentiate. And this linear function here, that just stays there. So that's probably the easiest part. The main thing to remember is what changes into what. For instance, sine will change into cos. And for those of you who are wondering where all this comes from, well, you can do it by first principles. So you just need to have a bit of extension 1 trigonometry in there with the compound angle formula and use the limits we discussed in the previous lesson. But all of these identities are derived from first principles, differentiating. So let's have a look at the next one. So let's say we have y equals cos ax plus b, and if we differentiate that, we would end up with negative a sine ax plus b. So the thing out the front is the derivative. Cos will differentiate to give negative sine. Cos will differentiate to give negative sine. And likewise, this function at the end here stays the same. This stays the same. So the moral of this is cos will differentiate to give negative sine. And the tan now, if we have y equals tan ax plus b, we differentiate this, we'll get a sec squared ax plus b. So again, the derivative of this, and you can see a pattern emerging here, the derivative comes out the front, and this function stays the same, and tan will turn into sec squared. So these are the results from applying first principles. You just have to be familiar with the compound angle formulas and quite good with your limits. But yeah, this is what it turns into, and the moral of all of this is what turns into what. So if you're going to remember one thing from this lesson, and hopefully it's more than one, sine, if you differentiate it, it will turn into cos. It will turn into cos over here. Cos, if you differentiate it, will turn into negative sine. And if you differentiate tan, it will turn into sec squared. So let's have a go at doing some examples now. And you can apply the product rule, quotient rule, chain rule, all of these in your normal processes. This is just how we differentiate trigonometric functions. So let's say we have, what can we have? We can have y equals x cos 2x plus 1. We have to differentiate this. Let's differentiate this. So we'll note that we have a product rule here because we have a function of x being multiplied by another function of x. So we have a product rule. So we need to remember how to do that. And basically the product rule is you do them one at a time. So you differentiate one at a time. So I'll differentiate this one first, and I'll get 1 times cos 2x plus 1. I'll just write that as cos 2x plus 1. And now I'll differentiate the second one. So I'll differentiate this one. And doing so, we will get cos, well, out the front we'll have a 2, and it will be a negative 2 because cos differentiates to give negative sign. So that's what we'll have out the front. We'll have a negative 2 out the front, and cos turns into sine 2x plus 1 multiplied by x. So multiplied by this x here, because we're only differentiating one at a time. So what did we do there? Well, the first term here, due to the product rule, is we differentiate this and we keep this cos term constant. That was the easy one. The second term, it'll have a times x on the end because of this x at the front here, and we're differentiating cos this time. If we differentiate cos 2x plus 1, that will turn into negative 2 sine 2x plus 1. And that's the trigonometric part. If we differentiate this, it will turn into this. Cos will turn into negative sine. This function here stays the same, but we have the derivative of this out the front. We have the derivative out the front. So let's have a look at another one. Okay, this time we'll have a look at differentiating tan. So let's say we have y equals 3 tan 2x, and we have to differentiate this. So if we differentiate this, the 3 is sitting out the front, and let's differentiate tan. Well, we'll have the derivative of this out the front, so we'll have a 2. Tan will turn into sec squared, and that function stays the same. So that would be the derivative of this. You would get 6 sec squared 2x. We'll do one more, but it's just a case, the main thing is what turns into what. Sine will differentiate to cos, cos will differentiate to negative sine, tan will differentiate to sec squared. So let's have a look at another one. Which one haven't we done? I don't think we've done sine. So y equals sine, what about y equals sine x? Let's differentiate that. Okay, we differentiate this. The derivative of this is out the front, so it's 1. Sine will turn into cos, and that function stays the same. So if we differentiate that, we just get cos x. So sine x will differentiate to give cos x. Now, all the properties of tangents and normals and all of that stuff apply just as much with the trigonometric functions as they do with the other functions. So in the past, we've differentiated functions to find the equations of tangents and normals. And you can do the exact same stuff with trigonometric functions. So you can differentiate and find the gradient at some point by substituting in, and then go ahead and use this to find the equation of the tangent or the normal. And just remember that the equation of the normal, you need the gradient to be the negative reciprocal. So if we had y equals cos x, and we needed to find the gradient at, let's say the gradient at x equals pi, for instance, we would differentiate this. Oh, that could be a bad number. Let's say pi on 6. So if we differentiate this, we would get negative sine x, And the gradient at this point, the gradient at this x value would substitute it in, and we'd get y dash equals negative sine pi on 6, negative sine 30 degrees if you want, and that would be equivalent to negative a half. So that would be the gradient of the tangent at that point. And if we wanted the gradient of the normal, then we take the negative reciprocal of that. So the gradient of the normal at that point would be 2. And with this in mind, we can go ahead and we can find the equations of tangents and normals. And the equations of tangents and normals, we just plug it straight into here. The main thing is, once you've found the gradient at that point, it's pretty straightforward. Just sub in your x value, sub in your y value, and just clean it up, and you'll get the gradient of the tangents and the normals. So we'll leave that lesson there. It was a big lesson, and the main thing to take away from this is what turns into what when you differentiate it. Sine will turn into cos, cos into negative sine, tan into sec squared. So hopefully that wasn't too long and you got a fair bit out of that, because you'll probably be spending a lot of time differentiating trigonometric functions